Good afternoon. My name is Mohney. We're going to talk a little bit about HD voice, high definition voice, the overdue revolution. Specifically, we're going to talk about what HD voice is, how will you make HD voice happen on today's networks, who is doing HD voice, get into some very interesting questions here, and where you can find HD voice, high definition voice. Don't need that. Okay. Back in 2009, there were a bunch of events that took place that were kind of like a wake-up call for me and some other folks about delivering high-quality voice. First of all, France Telecom started beating its drum. They have over 5,000 G722 VoIP endpoints, wideband endpoints deployed. In addition to that, they turned up HD voice in Moldova. And why would you pick Moldova to demonstrate a bleeding-edge technology? Well, okay, maybe that's a self-answering question. Global Crossing, it very quietly built a conferencing bridge to support HD for its customers, for a customer, and it's working on a product for an open HD voice conferencing bridge where anybody can just call in and do a conference call in HD. Verizon Business has close to 5,000 HD voice phones, specifically Polycom phones, if there are any Polycom fans in the audience. Installed at their headquarters in Basking Ridge. Verizon expects their early adopters to come by later half of this year and have general availability of HD on Verizon's business network, not to be confused with Fios or their wireless network, in 2011. And then Cablevision deployed a hosted HD voice service in the second half of 2009. So we're left with this quandary. Either A, once again, the United States of America is being outclassed by the rest of the world in telecommunications technology. How many of you think that? Or the other half, U.S. carriers are going to wait until the smoke clears and then get a deal done because somebody else has done the hard R&D. Hard to say with some of these carriers. First, what is narrowband voice, or what does it mean? Narrowband voice is basically what you get on nearly every POTS, plain old telephone system, wired or wireless call today around the world. And I'm going to ignore ISDN and the mobile HD voice deployments for a moment. A PSTN grade call captures voice in about a 3.4 kilohertz range, 300 hertz to about 3,400 hertz. So what happens is you're hearing of a human, what that 3.4 basically you get about a third delivered on an average phone of what you can actually hear. Now, that acoustical standard was set back in 1937, and since then we've had FM radio, television, CDs, DVDs, HD TV, HD radio. We've had all these audio advances, but the fundamental phone system around the world has not changed since 1937 from an acoustical standpoint. There are a couple of exceptions, we're going to ignore them right now. Now, the VoIP equivalent, the voice over IP equivalent of narrowband is G711, and it delivers that 3.4 kilohertz of sound at about 64 kilobits of bandwidth. Now, if you think about it and you stop for a minute, landline phone has otherwise, every other technology in landline phone has changed since 1937. The user interface has changed, the way you connect calls has changed, the network has all changed. If you just pick up your phone, back in 1937 they had a dial on it. You had pulse dialing, you had a cord in the wall that was wired into the wall. You walk in any home today and it's like, unless you're a member of the professionally paranoid, you don't have a corded phone in your house. You have a cordless phone, and it's got buttons on it, and it plugs into an RJ11 jack in the wall. Okay, so what is HD voice, as I've set that up? HD voice is also called wideband voice. Now, what that means is that it delivers voice in a range of at least 7 kilohertz, in other words, twice that of a narrowband call. Or if I do my Tom Cruise imitation, this is you on narrowband, this is you on HD. Narrowband to HD. If we turn to the how that's delivered in voice over IP, the G722 codec is basically the standard or baseline when people start talking about HD voice. And it captures sound in a range of 30 hertz to 7,000 hertz. But interestingly enough, you still only need that 64 kilobits per second of bandwidth, just due to the rather mellow amount of compression that G722 does. Other HD voice codecs that we'll get to a little bit later include something called AMR wideband. Silk is pretty popular among the Skype crowd. And then there's another codec called ISAC that's made by Gips. One of the key takeaways here is HD voice is only delivered on a digital network or an IP network. That the current phone system, POTS phone system, just can't handle it because it's all analog. And all the handsets are legacy, and I don't know, you can't talk codecs to an RJ11 phone. The sidebar, there's a lot of hype coming out about super wideband, or codecs that sample nearly the full range of human speech. Now, I know I'm mixing and matching some of my terms here, but typically the sampling is 8 kilohertz sampling for narrowband, 16 for wideband, 24 hertz for super wideband. Beyond that, you're sampling for your dog to hear it. Super wideband in some cases is basically marketing speak for we're better than G722 in a lot of cases. But on the other hand, as we'll hear in the demo, super wideband comes as close as you can get for delivering, true voice, just like you and I sitting across and talking to each other. Looking at the stuff from a different perspective, when you start talking about hertz, this is probably the best visual representation. First column is your voice, basically more or less what it looks like in hertz. Human hearing, more or less of the amount that you can hear in terms of hertz. Narrowband call, that is that little dinky bar right there in the middle. Then you go to HD voice, the bar next to it, and then super wideband next to it. So there's a gradual progression as to how much more information that you deliver, the better the codecs get. Now, since we talked about HD, we're going to try delivering it.
To be married to a VoIP geek is not that bad. I have all my Friday evenings to myself. I can go out, have a drink, see my girlfriends. Then I come home, I cook a nice dinner, and I wait until the conference is over, just hoping my dinner won't be totally burnt.
Okay. Now, what you actually heard, the first third of that audio clip was narrowband. The second third was G722 HD voice, and then the finishing part was super wideband in G722.1c, one of the Polycom Siren codecs. Now, as you could tell from a subjective viewpoint, the biggest jump in clarity is from when you go from G711 up to G722, and then you got a further improvement once you went from G722 all the way up to 722.1c. And the other thing that this clip and the other clip that I'm going to play illustrates quite clearly is that one of the benefits of HD voice is that if you're trying to interpret or listen to somebody who doesn't speak your own language, you get you get a much more clearer understanding when you've got that extra audio information to play with in your head. So I'm going to play another contrast example. The other thing that happens in this contrast example is that as you're going from left to right, there's a screen graph that's giving you the energy of or the amount of information being captured in hertz that as it rolls across.
Hi everyone, my name is Michael Edema from the Escozia PBX project. We're currently developing an Asterisk-based firmware for low resource or embedded systems, and currently porting from FreeBSD to Linux onto 2 different CPU architectures. So I'm unfortunately unable to attend this year. We're just a little bit backed up. I also have a cold, which you might be able to hear in exceptional quality right now. Have a great time at AstroCon. We're going to be there next year. Bye-bye.
So you kind of hear the difference between the 2 or the 3 different samples. But the benefits are there's 2 major benefits from moving from narrowband to HD voice that a lot of people have been hyping about. First benefit is there's better compensation and better clarity. When you compress something down into narrowband, that chunk of narrowband, similar sounding words like sail and fail start to garble. And then if you get into a situation where you're rattling off a lot of acronyms like FCC, FTC, things like that, those are notorious for getting garbled, and you have to either spell them out or you have to repeat them. In addition to that, as you kind of got the impression from the clips, narrowband is a big headache when you're in a multilingual setting, when you're trying to talk to somebody else that doesn't speak your own language and vice versa. The second thing with narrowband is reduction of fatigue, and this is also called why conference calls suck. Does anybody like conference call here? Anybody? No, nobody likes conference call. Well, there's a reason for that, and there's actually a physiological reason for that. That narrowband clipping that we've all taken for granted means that in the background your brain is playing fill in the blank as a background task in your head to fill in the information between what you're hearing in narrowband and what it should sound like in wideband, or if the guy was sitting right next to you. The net of this is the more audio data that you can deliver to the ear, the less your brain has to compensate and figure out what somebody else is saying. So this is the reason why you don't look forward to conference calls, even though you don't realize it. Your brain has to actually do some work other than sit there, or you can ignore the conference call and sit there anyways. But if you're trying to listen in on a conference call, trying to interpret what somebody else is saying, it's a pain in the ass. Delivering HD voice is more than just a codec. You need to have a codec that can capture the sound, and you have to be able to have the software that moves that from point A to point B in terms of quality of service. You have to have the hardware that can actually capture that range of sound, a solid network, and then if you're also trying to do this on a large scale, you have to have IP or SIP interoperability in order to move call from point A to point B. So in most cases, doing HD voice is an all IP or SIP application for the networks of the future, anything that we're talking about broadband. Number one. Number two is that you do need more capable speakers and microphones on your phones because the audio PSTN, you just can't backfit that because, again, those parts are engineered to capture narrowband. They're not engineered to capture wideband sound. Again, you need good quality of service. You need low latency in the network. Basically, if you can't do vanilla VoIP in terms of quality, you aren't going to be able to do HD voice. And then finally, for scaling, I'm going to get a little bit more into this further down the presentation. You need to have agreements to interop or to interconnect via SIP for seamless HD calling, and then you also have to have a mechanism for transcoding. So I'm going to walk through this one by one. HD voice codecs. There are 4 codecs kicking around that what I call the codecs that really matter. The first codec, that is the gold standard, or the old standard, depending upon how you feel, is called G722. Basically, it was developed in the 80s. The patents have expired on it. Now anybody can use it. Now everybody does use it if they're building IP phones these days. The next codec is called AMR wideband, or also G722.2. Now, the cellular industry over in Europe wanted a codec based on their original AMR codec standards. Now, the reason why they wanted AMR wideband is that it was designed to conserve usage of radio frequency, so you could basically put an HD call into about 24 kilobits a second versus the 64 kilobits a second you need with G722. The downside to AMR wideband is that you need to pay VoiceAge and Motorola and France Telecom and Ericsson for patent use if you actually put it into a handset. Right now, AMR wideband is currently exclusively in a cellular domain, but some of the patent holders of AMR wideband want to see that codec move into wireline. There's a big push on it. The third codec of note is called ISAC. ISAC was a codec that's been developed by Global IP Solutions, or GIPS. Now, Google turned around and paid $68 million for GIPS back in May. ISAC is licensed for practically nearly every software client on the planet to deliver voice, including AOL, Yahoo, Nimbuzz, WebEx, Citrix Online, IBM's Lotus. The big question right now is if Google will take that ISAC codec and open source it, or open source other codecs within the GIPS family, like it did with Google has done with the video codecs that it's bought and as open sourced. Now, finally, kind of like the dark horse in this race is Silk. Skype wanted a super wideband codec, something to brag about, which had variable bitrate adaptability based upon the CPU you had and the network that you have. It's got a royalty-free license, and then it samples anywhere between 8 and 24 kilohertz and uses anywhere from 6 to 40 kilobits a second for bandwidth to deliver a call. Skype wanted something that could run on older computers, as well as run on the latest and greatest computers, and to run in a wide range of bandwidth availability. So to handle anything from dial-up all the way up to the latest and greatest fiber connections. But everybody wants to do codecs, so there's more codecs. Polycom has a whole host of codecs, like the one that we heard, G722.1, the Polycom Siren codec, that's royalty-free. You've got Frauenheimer Audio Communications Engine, or ACE. The people who gave us MP3 are also pushing the AAC codec for delivering HD voice. But of course, if you get it and implement it, you have to pay royalties on it. SpeechX is an open source codec that's been floating around, and people give lip service to that. And finally, Broadcom has released a bunch of codecs for its chipset. This is significant because a lot of phones use the Broadcom parts. So why do people fight over codecs? Well, number one, developers, all programmers think they can write something better. If you look at it from a hardware perspective, simpler is better. From a hardware perspective, if you're building a phone or you're trying to do an implementation, the fewer codecs are better because you have less expense to test and verify and support codecs. So hardware guys, they want as few codecs as possible. And on the device side, especially more with mobile devices, the less processing you do in the phone, the longer battery life that you get. Common sense. The wireless crowd, they have a different view. The wireless crowd likes to lean on the device CPU in order to do data compression, and that includes things like AMR wideband and SILC. That's because the old guard in the wireless crowd believes that every little RF bandwidth is sacred, and you need to conserve bandwidth within licensed bands. The problem is that statement goes out the door when you start talking about 3G networks and 4G networks, where a 64 kilobit setup for a voice call is nothing. And still carriers say a straight, carriers and people pushing AMR wideband say with a straight face that we need to conserve bandwidth, all the while they're rolling out streaming video services and two-way video services. It's like, give me a break. Finally, when you get to network core, the guys that are switching phone calls back and forth on the service providers, you have more codecs, you have to do more transcoding. And again, it becomes a support issue. It's a pain in the ass to do. In addition to that, service providers want to avoid transcoding because it does cost them money because either they have to buy bigger boxes to do to support more codecs for transcoding. And then the other concern is that you lose some HD voice goodness. When you translate, you may lose some HD voice goodness if you translate between one HD voice codec into another HD voice codec. As a side note, the cable companies and France Telecom are embracing a standard called CAT-IQ, which doesn't have to do transcoding at all. They've got there's some standards floating around that allow you to do end-to-end an end-to-end call in G722, where both sides can even be on a wireless handset. So that's pretty cool. Software clients and hardware. Again, if you have a soft client you download, there's plenty of them floating around that supports G722, or they already have ISAC already built in. And then, of course, there's one big one, Stripe, that already supports SILC. Hardware-wise, if you buy an IP desktop handset today from any of the name manufacturers, and even from a lot of the no-name manufacturers from China and things like that, they've all got G722 built in as support. For them, it's a relatively cheap thing to throw in terms of throwing the codec in. But the flip side of that is some of these guys advertising that they support HD voice may not have the good acoustics, that is, the higher quality microphones and speakers, in order to deliver that full experience of sound. Now, on the mobile device side, it's a little bit more interesting. You do need good acoustics. So you need a little bit better microphone, or you need to. But one of the other things that's happening is phone manufacturers are starting to stick in dual microphones into handsets, so you can do things like echo cancellation or noise cancellation to get a clearer voice. So how do you get HD voice users? to talk to other HD voice users. How do you get these guys to talk to the PSTN? After all, the PSTN's not going away tomorrow. The simplest case is if you have the same codec type when you're trying to make a phone call. And if you're on the same LAN or network, as many of you may find if you're at if you're at a college or university or your business uses it, if you're all on the same network, you're all using the same codec, you're all behind the same firewall, you can just call John over in the next office, or you can call Bob upstairs, and it just happens. The problem is when you start to move beyond the demarc in your firewall, or the demarc or move at where the security barrier is at a service provider, and then after that things get to be a lot trickier because there has to be a more formalized negotiation for security reasons. Okay. Now, for different codec types, we also have to get into things like transcoding, where you go from either HD voice to the PSTN, and it's kind of accepted. Everybody realizes, again, the normal phone system isn't going to go away anytime in the next decade, so you need to be able to downshift from wideband down to narrowband. That's easy enough to do. The thing that gets upset is that if you do have to touch the PSTN, you lose all that goodness of the HD call in the first place because you're basically cutting out all that sound. Not really a net gain there. Secondly, and the thing that's getting people to gnash their teeth a little bit more is when you have to translate between G722 to AMR wideband, service providers get a little bit annoyed, but not really, because they accept the need to translate between HD codecs, i.e. like G722, which is already there, and AMR wideband, on the mobile side. Now, HD voice in the island problem. If you want to scale up, you need to be able to interconnect at the IP level via SIP to have a seamless end-to-end SIP call anywhere on the internet or anywhere on a broadband network. Now, the thing is that service providers don't do SIP peering, IP interconnection, federations, whatever you want to call it, out of the box. Now, why don't they do that? Well, there are a hell of a lot of security considerations when you start talking about VoIP. You've got SPIT, you've got DDoS, Go back through DEF CON for the last 5 years and dig out everything that, all the security headaches that you can find with VoIP, and there's the argument. A second headache is that enum, that is translating between the normal 10-digit phone system on the PSTN and mapping that to a phone call, that gets to be a little bit of a headache. There's a quality of service issue because service provider A wants to make sure if they make a phone call to service provider B, it goes through with high quality of service. That has to be negotiated at a higher level. And then finally, there's an argument as well, if I place a call this way, who gets the money? Now, as a result of that, of all the security issues involved, there are a lot of HD voice islands running around within enterprises as well as at service providers. So the task of the day for HD voice to move forward is building HD voice bridges, building all these interconnects between everybody doing HD voice. There's 3 ways to do this. You can have a direct relationship between a service provider and service provider, and build a trusted relationship where the service provider A and service provider B can do that. Number 2 is you can interconnect or federate with a third party in a spoken hub network fashion with whoever your hub service is, handling all that overhead of enum, SIP, the technical issues, some of the business issues and legal issues involved in terms of exchanging SIP. And then finally, the third solution that's just come out recently is you can buy a box from Cisco if you happen to have a Cisco product, and you can interconnect automagically with this Cisco IME box. SIP federations, there are like 2 major players in the SIP federation club right now. Number 1 is a company called XConnect based over in London. They've been running an HD voice trial for IP interconnect basically since the April of this year. The trial's still going on. The problem that they seem to have is they haven't made a big value statement or a value proposition to a lot of folks as to why people should pay money to subscribe to their service. The problem right now is that there are a lot of little guys that can do HD calls, but if I have to pay a couple $1,000 a month for that service, that's a lot of money when I'm only going to have a low probability for an HD voice call to go from point A to point B cleanly. So there's a little bit of a chicken and egg problem there. The second people that could do SIP interconnect if they woke up and do it is a Sprint. Sprint's got the PIN network, and that's not no Candice Bergen dropping a PIN. That's the partner inter-exchange network. They built an architecture that can handle a full range of rich media, SIP stuff. But right now, the only service they're running over it is vanilla VoIP. And part of the problem is right now they're in the mindset that they're treating us just like a regular voice call when they terminate calls. So they want a price per minute on the call, and they want termination fees. And that doesn't really work in a VoIP world where all you do is you plug in the Gigi Ethernet and it just happens. Now the third way to do it is Cisco's got a product out called the Intercompany Media Engine. Has anybody heard of that? No? Okay. Cisco basically built this magic box to get around the issue of having to have service providers or large enterprises directly peer with each other. Basically, there's an appliance that you plug in. You load into this appliance all your SIP devices that have phone numbers, and that can be HD voice phones, regular IP phones. That could be the cutesy video phones. That can even be telepresence rooms. You load all of the phone numbers into their magical box and you turn it on. And what the magical box does is talk to all the other IME boxes. Well, it talks to first of all, it talks to a dynamic hash table and publishes all those phone numbers that have been entered into it into a large dynamic hash table that's capable of handling up to 10 billion entries, a lot of phone numbers. And then what happens is these boxes just sit there until somebody from another, also that owns another Cisco IME box, the two call each other, and then with a regular phone call. And after that first regular phone call, they take the information from that regular PSTN-based phone call, and they like length of call, when it started, when it stopped, and they treat that as a shared secret. And then the two Cisco IMEs wake up and go, "Why, you have HD," and "Yes, I have HD," and then they exchange security information, and then subsequent calls. After they exchange security information, then the IMEs know that if this phone number is called, I can just route that straight over the internet. And then subsequent calls after that get routed on a virtual SIP trunk that gets set up each time a phone call is made. And again, any calls made in that fashion can be anything from vanilla VoIP, HD voice, video, or anything else that you can do that's SIP-based. Now, the IME engine is also interesting because if you look at all the standards that Cisco's proposed, some of those standards were written by a former Skype employee, so you see where that whole peer-to-peer architecture comes into play and why it comes into play. Realistically, though, the biggest headaches for HD bridges are layers 8 and 9. Layer 8 is money. Layer 9 is politics. In layer 8, when you start talking about money, voice providers are used to terminating calls are used to getting paid for termination and on a per minute basis for long distance calls. And whenever you start talking flat rate to your phone company, they start to tilt a little bit. They just they've reluctant. A lot of phone companies reluctantly, they will do flat rate plans. But you dig a little bit harder, and there are certain services where they still do termination calls and per minute charges. Now, service providers are reluctant to pay the upgrade for infrastructure, that is, pay for a Cisco IME box or pay for the overhead to negotiate peer-to-peer exchanges with other service providers, because it's currently a very small universe of phones that make HD calls, but that number is growing every day. And then interesting, though, Verizon Business has decided to provide free SIP calling in its Viper service to its customers. Now, layer 9 in politics, there's a lot of jockeying going on by smaller players that want to get together and peer, and so they can build up their own big universes to exchange VoIP calls, directly bypassing the PSTN, and yes, directly bypassing the old style termination per minute charges. The larger players are moving slower to IP interconnect. It's on their radar, but it's not on their list of things to do, because once they implement that regime, then that starts cutting into the bottom line that they're making from settlements and termination. Will see the cable companies start to do IP interconnections next year so they can exchange VoIP calls. Applications that love HD voice. Conferencing is a killer app. Again, there's clarity, there's less stress, you can identify voices, accents are much less of a barrier. When you get into multinational conversations, that's a bonus dollars, because again, with non-native speakers of different languages, you can better understand what somebody's saying, and you can better understand what's being said when you start to throw accents in. And third, the other application that loves HD voice is transcriptions. When you go for things from like voice to email, if you're using computer-based or human-based things to do transcription, HD voice gives you, it's easier process, there's less errors, so HD is a big win there. Applications that should love HD voice is anything to do with processing voice like IVR services and stuff like that. The young and old. If you've ever made a phone call to anybody under the age of 3 and you just hear the squeaky little voice on the other end and you go, let me talk to your mommy, and then, okay, what did she say again? The problem is that narrowband, you can't understand what kids say in narrowband because they have that higher pitched voice. And then, they're speaking and all their energy's up here and that narrowband's down here. You don't understand what the hell they're saying. And again, if you're older, HD voice adds in that extra information so you can understand what they're saying better. Public security and national defense, there's been an argument that if HD voice is implemented, you get better 911 calling rather than trying to figure out what somebody's saying in a panicked voice, a high-pitched voice. And there's also been some suggestion that if you put in HD, there's better translation and understanding of intercepts. Yes, this is one area where we do want the enemy to have the latest and greatest technology so we can understand them better. Who is doing HD voice? Well, there's a lot of people and a lot of players on the service provider side. You have major telecom carriers, the mobile carriers, cables and MSOs are doing some work, hosted VoIP guys, and even smaller consumer plays. And then we'll get into by region. Major telecom carriers for broadband HD voice solutions. In broadband, France Telecom is the loudest guy. They've got 500,000 endpoints turned up as HD voice right now. Verizon's got about 5,000 endpoints internally, and then Verizon Business is going to start supporting HD voice through their VoIP Enterprise Exchange service by the end of this year. They're testing it out now. They probably have some guinea pigs in a couple of their favored customers already. BT, the BT Hub service is a G722 service. Does anybody have a BT Hub? No? BT Hub is a HD voice service. It's just the Brits don't know what the hell to call it, so they call it like high definition voice, something weird. But it's not, they don't call it HD voice like everybody else does. Telstra has a hosted HD voice service for businesses down under. In addition to that, Telstra has up to 11,000 endpoints using HD voice internally. They're probably, at one point they were the biggest single carrier using HD voice. That's probably starting to shift a little bit as Verizon and other folks get traction. Global Crossing, as I mentioned before, they're doing some stuff in HD voice for their high-end customers. Now, there are other carriers that have been rumored to do HD voice on the broadband side. Telecom Italia, some of the Nordic telecoms. In addition to that, there's been a rumor that I haven't been able to confirm that AT&T is running HD voice trials down in San Antonio in their home headquarters. But AT&T isn't commenting, and I can't find anybody who's got a phone in their house down there. Can't find a friend down in San Antonio, basically. Mobile cellular for HD voice. What's happening is the positioning is if you're running a 3G plus service or running Volga, voice over LTE, or 4G, these are all going to be drivers for HD voice, higher quality voice services. There's kind of a recognition among the cellular carriers that voice quality among the cellular carriers suck. And France Telecom in their Orange brand has been very aggressive in pushing HD voice. They've already rolled out service in Moldova and Armenia. France is supposed to be done by the end of July. That is now. They've been doing trials in the UK for HD voice, and the rollout is expected later this summer. And in addition to that, FT has also said that they're going to turn up HD voice mobile service in Belgium, Luxembourg, and Spain by the end of this year. And then you can throw in Tunisia on that as well. Why Tunisia? Well, the pattern is that France Telecom spends a lot of money deploying what they call these 3G networks or advanced mobile networks out there. And basically, again, Moldova, Armenia, Tunisia, they're all greenfield builds. There's no legacy equipment in there. France Telecom just rolls out the latest and greatest equipment in there, the most modern switches. Once they turn up all that stuff, all you need to do is have an HD phone have a mobile handset that supports HD in that network, and you've got HD, basically for the cost of turning up the network. In Tunisia, Orange, France Telecom has invested up to €500 million to build out this 3G plus network. So if you're going to build a network with that expensive, it goes to assume that they're going to stick HD on it. SFR is testing in France now, and they expect I expect to shoot HP shortly. 3UK has demoed HD voice, and then Deutsche Telekom has trialed HD voice on LTE. They did it sometime in the past 2 years. They haven't put their cards on the table yet, but it's pretty sure that when the time comes, probably when there are more mobile handsets in the pipeline, they'll probably turn up HD voice somewhere or another. Cables and MSOs, I hate to quote Battlestar Galactica, well, the Cylons have a plan. Well, Cable has a plan. And Cable's plan is basically, they've issued multiple standards relating to HD voice to implement it. They issued both an IP interconnect standard and the DEC Cat IQ standard, where you can do end-to-end calls between point A and point B for HD voice. In addition to that, Cablevision, kind of like the bleeding edge guys in cable, they've got a hosted HD voice service turned up now. Cox, all they'll say is they're looking at turning up HD voice in 2011. Comcast, their CTO has basically dropped said that as the company moves to HD voice, when they start moving phone calls off the regular phone system, they're going to turn up HD. But then any follow-ups to Comcast are like, well, we're not going to comment at this time. So they were being real assholes about it. I mean, basically, their CTOs talked about it, but they're not going to put a timetable out there. And then Time Warner Cable has tested HD voice in their labs, and then every time you try to pin them down on a deployment date, they go, well, within 5 years. But they won't. They just won't. They just don't want to put their cards on the table. And for all the cable companies, they want that all of them see money out of the enterprise. They kind of like maxed out residential, or they milked the residential. So they see HD and also just businesses making money off of businesses. So they want to do, so as they deploy SIP trunking and more hosted services for businesses, you're going to see HD roll out as a part of that package. Business VoIP providers, there's a lot of independent hosted providers in North America. They've been doing HD voice for a couple of years just to differentiate themselves against the Verizons and the AT&Ts of the world. 8x8, you'll find them in Staples. You can walk into Staples and buy an 8x8 phone and service. They're the biggest guys in North America doing HD right now. They use Astra phones, IP phones. Right now they've got between 130,000 and 140,000 endpoints deployed, by the end of June. There are numerous little guys with anywhere from 2,500 to 7,500 endpoints doing HD around the country. And then there's also been a lot of talk, and I think some of it's just smack talk, among the smaller guys for basically getting together and peering all their IP phone numbers so they can deliver HD voice and other services. There was last fall there was an IP Peering Alliance press release about how a group of bold and brave, independent VoIP providers would all get together, and the one press release came and they haven't done dick. And then this earlier this spring, then there was an announcement from a Cloud Communications Alliance, which seems to be a more formal group of the IP peering people. They've said, well, we're all going to get together and we're going to do all these wonderful things, and then we're going to build this whole huge HD voice, interconnect. And you haven't heard anything out of them since. So digging through a little bit more, half the guys that are in the XConnect trial belong to the IP Peering Alliance, and they've also tried to do some interconnections with Broadsoft. Independent consumer plays, there's a couple people that are doing HD voice in the consumer world. You've probably heard the UMA commercials. The UMA second generation tele hardware both supports G722 as well as the Cat IQ wireless HD voice standard. In the fourth quarter of 2009, UMA shipped 25,000 units. You do the math conservatively, UMA could ship up to could have deployed up to 125,000 units doing HD voice by the end of 2010. But UMA was very, very rah-rah HD voice initially. This year, earlier in the spring, they took a left turn and they started talking about great voice quality, narrowband, and it's just like, guys. Now the guys that did the Ojo phone, WorldGate, they also come out with a second generation video phone, and they've got this 2-year, 300,000 unit deal to ship video phones to ACN, and it supports both video, but it also supports G722. HD voice by region, as noted, Europe led by France Telecom. You're starting to see a lot of movement there. Asia, Australia, and Telstra are offering hosted service right now. Korea and Japan are offering HD voice services, but it's hard to tell what once you translate stuff through Google. And then again, in North America, you've got a lot of stuff going on under the radar. And then finally, Africa and South America, if you're talking about greenfield rollouts of 3G, 4G networks, they're going to have good potential to have HD voice just tagging along. Drivers for the HD voice today, I'll flip through this real quick. Service providers like HD because there's an attraction there. France Telecom, their orange services like Experience Emotion, and it also allows them to showcase the latest and greatest technology that they've got. They're also thinking that they've got a better quality product. It keeps people from switching to another service. France Telecom's not charging extra for broadband HD. Now, the big question for service providers, well, how do we make money on HD? Nobody knows. There's one possibility is that in a prepaid versus postpaid world, in a prepaid world, you might just get a PSTN quality voice. In a postpaid world, that is where you hand larger checks to the phone company on a regular basis, HD voice might be the quality of service. HD voice is something you might have to pay for and sign up for on a regular contract, but nobody knows. Again, conferencing HD voice is killer app, because you get clear information, it's less stressful. Multinational, again, I'll flip to this. Don't care about UC. There's a lot of people in higher ed like to play with cool toys, and so you're starting to see large deployments of HD in places like Penn State and Texas Tech. Who companies in the HD ecosystem? Again, you got people like, I'm bleeding. You got BT, Cablevision, France Telecom, Verizon Business 8x8. All the IP desktop handset manufacturers do HD voice today. With mobile handset manufacturers, both Nokia and Sony Ericsson are supporting HD voice on France Telecom's network today. All the other phone manufacturers are in the pipeline to support HD voice. LG is probably one of them. Basically, if you went to France Telecom's website and looked at all the vendors supplying them phones today, they're probably going to be supporting HD voice by the end of 2011 because France Telecom, they want HD in all their phones by the end of 2011. And you got people like Cisco, Dialogic, Ericsson supporting HD at the network core as well. Okay, so how does this all roll out around the world? Macro picture of HD voice today. There's a lot of technology. Technology is out there in abundance. We don't have to reinvent the wheel. It's already out there. And as I noted before, there's a lot of HD islands out there at enterprises and smaller service providers, and soon larger service providers are going to get turned on to HD, like Verizon Business is turning on their service. There's a lot of HD islands out there. So in the near term, IP interconnect is coming. The hurdle is getting past, again, layers 8 and 9, the money and the politics issues. People need to figure out how they're going to make money or how they're going to save money doing HD. Number one. Number two, they need to get past the politics of, well, how do I screw Bob, or I can connect to Bob and it's not going to hurt me. They have to get through that mindset. Longer term, you'll hear about super wideband coming along as a codec or CPE upgrade. And the reason why is, well, the question in my mind is, are people going to push for super wideband or not? And the answer is, who the hell knows? We've sat around since 1937 with narrowband voice, and we're just getting around to upgrading to HD. Super wideband may take us another 20 years. It may not, because upgrading to super wideband is just a codec and an end user hardware. So you look overseas, mobile HD voice is going to happen faster. The reason why is a typical handset Life cycle is about 3 years plus minus. Japan slightly faster. In the U.S., a little bit more, but it's an arms race. These guys make money off of selling handsets, so plugging in HD, plugging into mics, that's the latest and greatest stuff. So the more features that they can add, and the more that faster processors help them, the more they can do HD. Broadband. The most interesting part about talking about broadband is that Verizon, it basically is going to boil down to Verizon versus AT&T, who blinks first. Cable companies are on their little path to have HD voice generally available both for residences and for businesses and probably residences in the 2011-2012 timeframe. And the general consensus is that once one large carrier like a Comcast or Time Warner does it, everybody else is going to have it because they have to be like the Joneses. Okay, so for more HD voice information, you can visit the website, find the presentation on there on WWHD Voice News, and there's some other resources as well floating around. But contact me. But anybody got any questions? Yeah.
So when would you guys predict when you might see HD voice on U.S. cellular? The U.S. cellular companies are just so hard to figure out. There's this, I would say that as soon as they figure out how to do VoIP over LTE, HD will come shortly after, because then it's just a codec thing. There's all this gnashing about Volga, doing voice over LTE, and they just established those standards. I'd say probably, no earlier than 2011. It'll be 2011, 2012. But I think, but basically, if you're going to do VoIP, from a purist standpoint, from a supported standpoint, if you're going to do VoIP, then you might as well do HD. Now, I can turn that on its head, and I can go over the top. If I've got a 3G or 4G phone, like an Android phone, then I can load in something like SIP-Droid or a SIP client, and then you and I could just talk. But from a GA perspective, generally available perspective, it's probably like late 2011, 2012. When mobile carriers exchange calls with each other, do they take advantage of the GM for that, or do they have I was just wondering like when self-provider like AT&T that you're not going to have events like you're going over business.
Well, everybody wants to move to do SIP peering. Well, it's complicated. The cable industry in general is starting to move to more federated model and using all SIP. Right now they just exchange calls and they do settlements. But more and more, but that gets to be more and more problematic because everybody's got a flat rate plan these days, unless you're doing on a prepay basis. So, other questions? No? Well, have a good one. I'm getting off the stage. Thank you very much.